Masonry Lintel over doors or windows, design and analysis using Tekla TEDs. So here is an example of Masonry Lintel, but this one is in British standards. So in this video, I'll demonstrate how to design in US standards. You just need to make sure you change the local to USA, and then I can start a new calculation. Then I'll go to Masonry, and I'll go to Masonry Lintel Analysis and Design, and then click Calculate. Now, if you have a stud wall, when you're designing a stud wall, over the doors and windows, you need to design a header to support. For example, if you're having a floor above, you need a floor header. If you're having a roof above, you're having a roof header. The difference is that for a floor header, you will be including the floor load. But in my case, I don't have any floor on top. I only have the roof. So this one is like a roof header. Now, if I go to Tekla TEDs, you need to make sure that let's say this window here is 8 feet. So my dimensions are 8 feet and bearing is 8 feet. I can leave the rest as default. And then the most important part is this part of loads. How do you know exactly what load and the magnitude to include here? Now, if you know a software called ClearCalcs, you have default loads for designing headers. So for example, if I add a new calculation, assuming it's just wood, and then I want a roof header, okay? Now, let's just say that my roof header is 8 feet long, just like my lintel, which is acting as a header on that masonry, on that CMU wall, okay? Now, the roof loads are typical. We have 8, we have 15 PSF, that is pound square foot. And then we have snow load of 30 PSF, and we have roof life of 20. We have wind down of 30 and wind up of -30. Now, these are the loads which are being converted here to linear loads, that is pound per linear foot. Okay. Now, the only difference is that instead of using pound per linear foot, we're using kilopound per linear foot. Therefore, it's just the same value divided by 1000. Okay. Now, because we're not designing a stud wall, we're having a CMU wall. Obviously, the weight cannot be same. The CMU is heavier. Therefore, I would leave, instead of using 30 PLF, that is 0.03 KIP per foot, I will just use this default value here of 0.477. Then we need to add roof life, we need to add snow load and wind. So the next load, I'll just insert load. This time I want roof live load. Okay, and from ClearCalcs we have a roof live of 0.28, because this is 28 pound. Change to kilopound, you just divide by 1000. We having 0.28. Okay, I will delete this point load because I'm assuming we don't have a point load anywhere. Now, for snow load is 0.42 because this is for 20 PLF. So I'll insert snow full UDL. Now this, let's change the type to roof live here. Change the type to snow. Then 0.42. Again, I can just copy and paste. This time, this one will be wind down. Change the type here to wind, and then it's just the same for 20 PLF. And I will paste again wind up, wind. This time, this one will be negative because it's negative for 20. And then the self weight, also the self weight of a wood header and the masonry lintel is different. Therefore, we just use the self weight a factor of 1. Then click OK. And the combinations, click OK. I'll go to beam details. Now we can just try this one. But if I go to here, I find that we need shear and also this tensional reinforced flexural design is failing. So I will need to increase the depth from 16 to 22. Go again back to design. Then you can see that this one is passing, but I can try to #4. Okay. Then click OK. We can try again to change to a more economical. Use try 20. Now we're finding this shear, so I'll just go with 22 to avoid those shear reinforcement. Okay. Now you can see how we determine the loads. Then finish. Now if it was flow, you can just come clear calcs, then search for flow header, and then the only difference is that you'll be having a flow linear load of 0 extra live load of 560 PLF at 0.5.6. So I'll just add on top of this in loading, paste, flow live load. Then this type will be live 0.56 and 0.14 for dead load. Paste, flow dead, change this type to dead 0.14. And of course, I realize that my flexure is failing. I can try at 5. Now that's passing. We need shear. To avoid shear, we can just increase the diameter to, let's say, 24 or something like that. So thanks for watching. See you in my next video.